Two sums to input array is sorted. Okay, so this is any medium layer problem. So let's see the problem at first. So we have given a one indexed array of integer numbers that is already sorted in non-decreasing order. Okay, find two numbers such that they add up to a specific target number. Let these two numbers be numbers of index 1 and numbers of index 2, where index 1 is less like greater than or equal to 1 or less than index 2 itself, and index 2 can be lesser than number that length. Fine, so that is quite obvious. Okay, so return the indices of the two number index 1 and index 2, each incremented by 1, as an integer array index 1 and index 2 of length 2. So basically we have to return the index array of index in the response, right? So the tests are generated in such a way that there is exactly one solution. You may not use the same element twice. Understood? So your solution will use only constant extra space. Okay, fine. So let's see the example one. So we have given num array 2, 7, 11, 15 and our target is 9. So target we can achieve by targeting indexes 1 and indexes 2 element, which sum is equals to 9. So that's why we're doing 1 and 2. Fine. In example 2 we have 2, 3 and 4. Our target is 6. So in this case 4 plus 2, like basically index in 1 and 3 sum must be equal to the target. So we are going to return 1 by 3. Fine. Example D is we have minus 1 and 0. Okay, so element can be minus as well. Fine. So here we have a constraint. We can see like number of arrays can be minimum from 2 to 10 to 3 to 10 to power 4 size. Fine. Nums of array can be vary from minus 1000 to 1000. So even like negative integers can be present there, but in like increasing order, right? And target can be also varies from minus 1000 to 1000, like quite equals to the given numbers of the array. Fine. So as here it is mentioned, like we can't use extra constant space, so we can't take any frequency array like or any hash map or hash set to store the visited element sites. So what we can do here is we'll go with the 2-pointer approach. Okay, so our first pointer will be pointing to the first element, like mostly leftmost element, and second point will be rightmost element, right? So then we are going to compare. Basically there will be two conditions we have to check. If the current sum of the left pointer and the right pointer is equal to target, then we are directly going to return the value of that current index. If it is not so, then we are either moving the leftmost index or pointer, we can say, or from the rightmost index based on the condition. Okay, so let's start. So we have given this method to find. We'll first take assign a left pointer at 0, and then we'll assign right pointer to the like rightmost means we can say numbers dot length. Okay, whatever, and we'll do -1 because anyways our current array is having index 0th index, right? That's why I'm taking -1, otherwise we'll give out of index array, right? And other than that I don't think we require anything like just 2-pointer approach. Now what we'll do, we'll run our loop, and we will check if L should be less than right index 1, and here you will check our condition if like current so numbers we have, the array name is numbers, so though so at L index, okay, plus numbers at right index. So right means whatever current pointer we have, if their sum is equals to target. So this is our the first case. If it is equals to targets, then what we do, we'll rightly return from here itself, and as we have to return the integer like value, right? So what we'll do, we'll create integer array here itself. Okay, and then I will return the length, the left index is another +1 and right index is +1. Okay, So if the current index is getting matched, then we are returning +1, because currently we are considering as 0 index, but anyways the index is has to be written in answer with the +1. That's why I have added +1 here, right? So if this is not the case, then we'll go to the another case. If else, here we will check if numbers of left index plus numbers you can say numbers of right index, if it is lesser, let's say if it is lesser than target, okay, then in that case what we'll do, we'll if the current sum is lesser than, that means we have to increase the sum. So by increasing sum, we have to move the left pointer in front, because it is increasing order, right? So we are going to increase our left pointer. If it is not so, then we'll simply go and we'll decrease our right pointer. So basically right pointer is the rightmost index, so we have to decrease to make the sum smaller, right? Okay, so by this part we are going to find this value, but in case if we don't find, what we have to do, it's not written anyways, after the loop we have to at least return some value here. So we are going to just return empty array. Okay, fine. Okay, now let's submit and let's see. Okay, so yeah, we can see like our all 3 test cases got accepted. Fine, now let's submit and see other test cases as well. Cool, so all 24 test cases got passed, beats 96%. That's quite good. And we have fulfilled even this condition, like no extra space we are using constant space for storing the our 2 pointer, like left and right pointer, that's all. And if we talk about time complexity here, so we are basically going to iterate each array in the rows cases. So yeah, like each element of the given array, so it is big of n anyways. So time complexity is big of n and space complexity is big of 1, because you are in constant space, right? So yeah, that's all for today. Let's see you next video. Bye.